All right, so here's a self-check here that is asking us to do some number conversion. And so we're asked to say what is the value of 25 expressed as an octal number. All right, so there's a couple ways that we could do this. We could go through the work of figuring this out on our own using the algorithm that we've outlined, or we can simply come up here and let's look at how we make use of this little base converter function. So the base converter takes two parameters. It takes the number in decimal. In this case, we're taking a decimal 25, and we want to convert it to the octal number 8. So the easy way to answer this question is to simply change the value of 2 there to 8, run the code. We see that 31, and that is correct. Okay, so how does that work? So let's say that we have our decimal number of 25 and our base is 8. All right, so let's follow this algorithm through. So dec number here is equal to 25. So we're going to calculate the remainder. So 25 modulo 8. So 25 divided by 8 is 3. 3 times 8 is 24. That gives us, so the remainder in this case is 1. Okay, and what do we do with that remainder? We push it on the stack. Now we calculate a new value for decimal number by dividing by the base. We already figured out that that was 25 divided by 8 gives us a 3. All right, so our new remainder is decimal number remainder base. Well, 3 divided by 8 is 0 with a remainder of 3. So let's before we forget our 1, let's put our 1 on the stack down here. It gives us a remainder of 3. So we push the 3 on the stack. Now decimal number is 3 divided by 8. Integer divide gives us 0. So now this is no longer true, so we drop out of the while loop. Easily enough. Now we create a new string. New string is the empty string. While the remainder stack is not empty, we're going to append to that new string, just like we did when we were reversing a string, is going to be equal to digits up here, our remainder stack dot pop. So if we pop a 3, 0, 1, 2, 3, now our new string is going to be 3. No longer have a 3 on the stack, and then 1, and so our final string is 31. Okay, so that's how that algorithm works. So now, get rid of that. Let's look at the next one. What is the value of 256 expressed as a hexadecimal number? All right, so we can change this, and we can plug in base 16, and if we run it, and we see that that gives us the hexadecimal value of 100. So if we plug in 100, we'll find out that we're correct. All right, so what is the value of 26 expressed in base 26? Well, all right, now you may think, let's try this. 26, 26, run, and we get 10. Now, that was kind of lucky because we don't have really enough digits in our digit stack here to truly do base 26. We only have enough digits here to do base 16. But if you follow this algorithm through, you'll see that we never really have to worry about that because we were only ever getting numbers down here in the 1, 0 range. If we had tried to convert 2026, 5, 14, let's try a little larger number and run, you'll see that we get a string index out of range. All right, so in order to convert up to base 26, we would have to modify the code. QRSTU wx, y, z. That's even more that we need in this case, but now if we run it again, we'll see that we get 1d5l. Now, so that's how we could have modified the code to do a higher base than 16. But let's go back and let's look at this again. So 26 is 1, 0. What is 2 in base 2? Also 10. What is 8 in base 8? Also 10. What is 16 in base 16? Also 1, 0. So the pattern there is that whenever you're asked to convert a number into the base that's the same as that number, you're always going to have the value of 1, 0.